there is now a page or tab called Prepare Data, and this is used with machine measured, machine digitized frame members to help prepare that data into a form where it can be more easily used as a boundary for a mesh surface or piece of fabric. There are tools to modify polys. The machine measured data usually comes in as a polyline, and quite often the polyline has a slight sort of jitter on it, or slight roughness, often caused by hand positioning during the measurements, and so very often we want to smooth the polys to fit a better shape through them, and these tools help with those operations. The first two tools in the modify polys, join polys and split polys, there are already in Rhino tools to split and to join, and sometimes the Rhino tools will be the best to use. However, the M-Panel tools are specifically tuned to work well with machine measured data that we want to take into boundaries, and so often the M-Panel tools will be the best ones to use. We'll just have a quick look at an example of using these. Let's say that we want to put in a piece of fabric, a mesh, over these surfaces here, over these edges here, and we have a couple of problems. One is that when we measured it, we included this front part, so this polyline here is going to need splitting, whereas this section just here was measured in two polylines which actually have a slight gap between them. Let's do this one first. Two polylines, join them together. We said they're not quite touching, can I fill the gap? And there the new polyline is drawn in. We typically have the old in red to compare it, and we can delete the old, and there's the polyline for that. On this side we have a single polyline which extends out past the frame area, and we'll split that. It's usually best to split in something fairly close to a vertical view. We say to split a poly, and we select the point to split, and we'll choose that point there exactly at the end. Again, we'll delete the old, and now we're left with two polys, and the difference between this and the Rhino method is that the M-Panel one always splits exactly on a measured point. There's often a bit of a difficulty when trying to measure with the machine frame members that come in towards a point like this, because it can be difficult to get the probe physically into that corner. And to cover that situation, we can extend those two polys to meet. Extend two polys to meet. And there the two polys are extended round and meet correctly in the corner. They're still separate polys, but they're meeting there okay. There's one other tool which is to offset a poly, and poly offset isn't used really in this situation with a simulated boat cover at all. It's used in the situation where you're measuring awning frames, and you can only measure perhaps on the bottom edge of the frame, whereas the actual fabric line that we want to connect to and use as a boundary is on the top edge of the frame. You can only get to the bottom edge either because of height restrictions or because of existing fabric which is already there, preventing you reaching through. And so what we want to do is to offset the poly by an amount which is equal to the tube diameter, and that's done, if I say a tube diameter of 1, I'll use this back polyline just here to illustrate this, and it simply draws a new polyline which is offset from the old one. Again, there are tools, similar tools in Rhino for doing this, but in many situations the M-Panel tool will be found to be easier to use. In this situation here now, we could go ahead and just add a surface between these edges. However, this edge here, which has been measured as, of course, as a polyline, a series of points, and each of those points will, because of hand positioning errors, just be very slightly out of position. There'll be a slight wiggle or jitter on those points. And we may get a better result if we replace that polyline with a smooth curve. And we can either just fit a simple smooth curve to the poly. The curve's smoothness is determined by the number of smoothing points. The more smoothing points, the more accurately the polyline will follow, the more accurately the curve will follow through these points. However, the higher the number of smoothing points, the more there will be some waviness in the curve. And so in general we use the smallest number of points that we can use and still get a reasonable fit. I would usually start with 4 and then work up in the number of points until I thought the fit was reasonable. If we know that the curve is planar, that is, that you could take this frame member off and lay it down flat on the floor, and that means the curve is planar, then we can restrict the curve to be planar, and that allows M-Panel to go in and make sure that the curve put in there is planar. And if in fact that tube curve has been created with a tube bending machine, and we know that it is actually an arc, then we can specify that we want an arc to go through there. So in this case I know that it's an arc, and here this draws in a smooth arc going through those points, and that smooth arc should get rid of any small measurement error, any small jitter that occurs. Again, I'll delete the old. And at that point I should be okay to go in and add meshes. I'd add an edge mesh between those 4 edges. We have some slight gaps, but there we get a satisfactory meshing of that shape.